Question 2. Evaluate the following. First question, tan square. In this, we'll expand the tan square as sec square x minus 1. As we know, 1 plus tan square is equal to sec square x. And we shift 1 towards the sec square x and we get as sec square x minus 1. We'll integral each function, integral sec square x dx minus integral 1 dx. So the integration of sec square x we have as tan x, and the integral of 1 is x. So tan x minus x plus c. Let's come to the second question, sine 2x upon cos x. We'll use the formula sine 2x as 2 sine x cos x upon cos x. Now here the cos x and cos x will get cancelled, so you are left with integral 2 sine x dx. We'll take the 2 common and we integrate sine x dx. So the integral of sine x is minus cos x. The answer you get as minus 2 cos x plus c. Question 3. Integral sine x upon cos square x dx. We'll separate cos square x as 1 upon cos x and sine x upon cos x. This is because sine x upon cos x we get as tan x, and 1 upon cos x gives us sec x. So integral of sec x into tan x dx gives us sec x plus c. Fourth question, cos 2x upon sine square x. So we can write cos 2x as 1 minus 2 sine square x as a trigonometry function formula, and denominator sine square x, we can split the denominator with 1 upon sine square x minus 2 sine square x upon sine square x. So here the sine square x and sine square x gets cancelled. So 1 upon sine square x can be written as cos x square x dx minus the 2 can be taken as common, and the integral of constant is x. So what we get as cos square x, that is the integral of cos x square x, is minus cot x minus 2x plus c. Fifth question, cos 2x upon sine square x into cos square x dx. We'll write cos 2x as cos square x minus sine square x upon sine square x into cos square x. We'll split the denominator with each function in the numerator, cos square x upon sine square x into cos square x minus sine square x upon sine square x into cos square x. So we can see over here the cos square and the cos square will get cancelled, and the sine square and sine square will get cancelled. You are left with integral 1 upon sine square x dx minus integral 1 upon cos square x dx. 1 upon sine square x can be written as cos x square x, and 1 upon cos x square x can be written as sec square x. Therefore the integral of cos square x we get as minus cot x, and the integral of sec square x we get as minus tan x plus c. Question 6, sin x upon 1 plus sin x dx. The first step is we rationalize the denominator by the conjugate, that is 1 minus sin x and 1 minus sin x. We multiply each one of them in the numerator and denominator. In the denominator we see that we have a plus b, a minus b, and the resultant function we get as 1 square minus sin square x. In the numerator we multiply sin x inside the bracket, so sin x minus sin x into 1 is sin x, and sin x into sin x is sin square x. Now if you see the denominator, we can write as cos square x, because 1 minus sin square x gives us cos square x. As we know, the identity is cos square x plus sin square x is equal to 1. Now we'll split the denominator, that is sin x upon cos square x and sin square x upon cos square x. And we integrate, we write the cos square x separate in the first function. So we write 1 upon cos x sin x upon cos x dx minus integral sin square x upon cos square x dx. Now in the first function we can write 1 upon cos x as sec x, sin x upon cos x as tan x, minus sin square x upon cos square x gives us tan square x. So the integral of sec x into tan x dx we get as sec x, and the integral of tan square x we split, we write it as sec square x minus 1, and the integral of sec square x we get as tan x, and integral of 1 we get as x. So the final answer we get as sec x minus tan x x plus c. Question 7, integral tan x upon sec x plus tan x dx. The first step is we rationalize the denominator. We'll take the conjugate, that is sec x minus tan x upon sec x minus tan x. We'll multiply In the denominator, if you see, we have a plus b and a minus b, which can be written as sec square x minus tan square x, which we get as 1. So in the numerator, we'll multiply tan x inside the bracket. We get tan x sec x minus tan square x. We integrate each function. So we get integral sec x into tan x dx minus integral. We'll split the tan square x as sec square x minus 1 dx. Integration of sec x into tan x we get as sec x, and integration of sec square x we get as tan x. Well, integral of 1 we get as x plus c, and that's the answer for the question number 7, sec x minus tan x plus c. Question 8, integral under root 1 plus sine square x dx. We'll make some adjustment inside the under root. We'll write cos square x plus sine square x in the place of 1, and sine 2x can be written as 2 sine x cos x. Well, if you see, we have cos square x plus sine square x plus 2 sine x cos x. This is nothing but a square plus b square plus 2ab. So we can write this as over here as a plus b the whole square, that is cos x, plus sine x the whole square. So the square root and the square will get cancelled. You're left with cos x and sine x. Integral of cos x will give you sin x, and integral of sin x will give you minus cos x plus c. Question 9, under root 1 minus cos 2x dx. Integral under root 1 minus cos 2x. 1 minus cos 2x can be written as 2 sine square x. We'll separate the coefficient, that is root 2 and root sine square x. So we can take the coefficient root 2 outside the integral, and we are left with integral under root sine square x. So here the root and the square will get cancelled. You are left with integral sin x dx. So the integral of sin x is minus cos x plus c. Therefore, you get as minus under root 2 cos x plus c. Question 10, sin 4x into cos 3x dx. Well, we'll do some fine adjustment. We'll multiply 2 and divide by 2. Is because that 2 sin 4x into cos 3x can be written as, we can apply the formula 2 sin a and cos b, and we can write it as sin a plus b and sin a minus b. So what we get as, we can take the half coefficient outside the integral, and we will be left with sin 4x plus 3x plus sin 4x minus 3x. So we get as sin 7x plus sin x. Integration of sin 7x we get as minus cos 7x upon 7 plus integration of sin x we get as minus cos x. Therefore, we can write half with each of the functions. We get as half minus cos 7x upon 7 plus 1 by 2 minus cos x plus c. Multiplication of 2 into 7 will give you 14. So we get as minus cos 7x upon 14 minus cos x upon 2 plus c. Well, thank you for watching this video. We'll keep posting you videos based on maths and other subjects too. Till then, subscribe and share.